Okay, guys, greetings. This is page 3 of the practice test. Okay, so let's look at this together. Let me adjust this because I want this. There we go. That's what I want. Yeah, that'll be okay. Okay, 15. Given f of x equals absolute value of x, g of x equals 2 times f of x plus 1. So, this is a transformation of this. Okay, so I've got things inside the function and multiplied. So I'm actually going to go right here. Write the equation of g of x. Okay, g of x is actually putting the parent function with this. So g of x is 2 times f of x, and f of x is the absolute value. So it's the absolute value of x plus 1. There's g of x. So that's what I'm graphing. I think I'm going to graph it in a second. So let's look. This is what I'm looking at. If I put these together, that's what I get. G of x is 2 times that function, so the absolute value, with x plus 1 inside that function. That's what that's telling you. So graph f of x. Let's graph the parent function, because that's a parent function. Okay, parent function is absolute value, so it's a v. This absolute value has a v in it. Vertex is right there, and it's just a V shape. Okay, so here's f of x. Describe the transformation. Well, every single one of these things that's different is going to make a transformation. So this plus 1, adding 1 on the inside. Remember, adding or subtracting on the inside is shifting it right or left. And it's going to do the opposite of the axis. It's going to opposite land. So adding 1 isn't going to shift it to positive 1. It's going to shift it to negative 1. So that's going to shift it left, 1. So shift it left 1. That's your first transformation. This 2, it's being multiplied on the outside. Anything multiplied on the outside, remember, is going to stretch it. So it's going to stretch by a factor of 2. Okay. So if I take this thing and I shift it left 1, always shift the vertex. So the vertex is here, and I shift it left 1, and then I'm going to stretch it by 2. So left 1, it's now the vertex is there. And to stretch it by 2 means instead of going over 1 and up 1 like I did on the parent function, you're going to go over 1, up 2. Over 1, up 2. And there is your function, g of x. So the transformations, anything adding or subtracting inside is going to shift it left or right. Adding shifts it left, subtracting shifts it right. Anything multiplied here on the outside is going to stretch it. If it's negative, it will flip it, right? Remember? And if I was to add or subtract things here on the outside, that would shift it up or down. If I put these things together, I get my equation. Now, let's look at this. 16. Given this function, g of x equals the negative square root of x plus 3 plus 2. The parent function. The parent function is the square root function, which makes this graph. It looks like that. And the equation is y equals the square root of x. So there's the parent function. Okay? I'd like this. I would love to see the equation. Write the transformation in function notation. Okay, in function notation, that's like here. So I'm going to take this function, which is the square root of x plus 3, and it's going to be the function. I'm multiplying it by a negative. I'm putting x plus 3 on the inside and plus 2. We didn't do a lot of that, but we did do some of it, okay? Now, I want to describe the transformation. Okay, I can go right back to here. This is a little bit above and beyond, guys. This, you need to be able to describe the transformations. Adding 3 on the inside. Just like up here, adding 1 shifted at left 1. This, adding 3 on the inside, is going to go left 3. This, adding 2 on the outside, is going to shift it up 2. This negative on the outside here is going to flip it upside down. So if I start, the parent function is the square root function. Looks like that. This function, I need to shift it left 3, so I start with the origin, and I go left 1, 2, 3, and then I go up 2, 1, 2. So there's my new starting point. And then if I flip that upside down, well, it's going like that. If I flip it upside down, it's going like that. So flip it upside down and over 1, down 1, because it hasn't been stretched. There's my new function. Okay? Now, let me do this for a second. Worst case, guys. If you're just like, I don't know how to do this, I can't remember how to graph it, make yourself a T-chart and put in a bucket load of points. If I put in a -3 here, it's going to spit out a 2. If I put in a -2 here, -2 plus 3 is 1. Square root of 1 is 1. -1 plus 2 is 1. It'll spit out a 1. If I put in a 0 here, 0 plus 3 is square root of 3. Negative square root of 3 plus 2. If I put a 0 here, and I just put a 0 in there and I dump that in my calculator, it's going to give me like I think it's going to be like 0.6-ish or something. But you'd put a point grad it. If you put a 1 in there, 1 plus 3 is 4. Square root of 4 is 2. -2, that's going to give you a 0. So if I put in enough points, I can just connect the dots, okay? If all else fails when you're making a graph, put in a bucket load of points and spit things out. Okay, moving on. Oh, cool. Guys, this is something you guys did really good on the last test on in general. I have two functions, f and g. Okay? Now, every time you see these, this is an input. This is not multiplied. It is not multiplied. This is not multiplication. It's saying take g and put -1 into it. Take f, put 0 into it. Take f, put 4 into it. Take g, put 6 into it. It's not multiplication. I can't say that enough. People that did it wrong generally multiplied. So if I take -1 and I put it into g, well, here's g. And g of x says it equals x plus 5 if x is less than 3. Well, -1 is less than 3, so I'm going to use that piece. So it would be -1 plus 5. That gives me 4. Let's do g anyway, again. G of 6. So now I'm going to put 6 into g. Well, it says g of x equals x plus 5 if x is less than 3, less than or equal to 3. 6 isn't less than or equal to 3, but it says g of x equals 2x minus 1 if x is greater than 3. 6 is greater than 3, so I'm going to put it in that piece. So I'd go 2 times 6 minus 1. So I put 6 in for x. And that's going to give me 11. Cool. F of 0. Well, here's f. Let's put in a 0. It says f of x equals 3 if x is less than or equal to 0. Well, 0 is less than or equal to 0, so it says f of x equals 3. Just equals 3. I just write down 3. Okay. So it says f of x equals 2 if x is greater than 0. Well, I look at the next one, f of 4. 4 is greater than 0. So it says if I put in 0 or any number greater than 0, it's going to spit out a 2. F of x equals 2 if x is greater than 0. So this equals 2. No work to do. It's just put it in and get it out. Okay. Piecewise functions, graphing it. Awesome. This is something people often did really well in. Graph the following. So first, find your fences, -1 and 2. So I'm going to put in my fences at -1, -1, -1, -1, -1, -1, and 2. -2, 2, 2, 2, 2, 2, 2, 2, 2. There's my fences. Now, who owns the yard? Well, -x plus 2 is here. Absolute value of x minus 1 is in the middle, and x minus 2 is over here on the right. Who owns the fence? I look for the equal sign. This is equal to. So this dude owns that fence. Equal to right there. There's another one. So this guy owns that second fence. So now find where they are. I'm going to make a T-chart. Make a T-chart, make a T-chart, make a T-chart. X, Y, X, Y, X, Y. Okay. So this piece, if I need to put in the fence is at -1. So if I put in a -1 here, negative 1, I don't want to do this in my head, so I'm not going to. -1 plus 2. Plus 2 and equals 3. So I put in -1, it spits out a 3. So -1, 3. -1, 3. That's where he's on the fence, and it's solid because he owns the fence. Now I'm thinking about this. Negative x plus 2, that's a line. X minus 2 over here, that's a line. So I'm only going to need 2 points on these. Put in another one like -1, -2, maybe -3. I like -3. Put in -3. So negative, and I'm going to go back to my calculator, -3, and it spits out 5. 1, 2, 3, 1, 2, 3, 4, 5 right there, and I connect those dots. If I didn't see what it was going to be, I just put in a bunch more points, put in a bucket load of points. I'm going to move over here, and I'll ignore this for just a second. X minus 2. The fence is at 2, so I got to put in 2. If I put in a 2 in there, 2 minus 2 is 0. So 2, 0, 2, 0. It's right there, and it's hollow dot because he doesn't own the fence. This dude does. Okay, let's put in 1, 2, 3. Let's put in 3. 3 minus 2 is 1. Put in a 4. 4 minus 2 is 2. 2. Put in a 5. 5 minus 2 is 3. So 5, 3, right there. See how they make a line? Put in enough points and you can connect them, even if they made a curve. Now, absolute value. That's a V-shaped one. So I don't know what this is going to do in here. I'm just going to put in a bucket load of points. But I got to put in the fences. So I got to put in a -1, and I've got to put in a 2. So if I put a -1 in here, absolute value. Is there an absolute value button on my calculator? I don't know that there is. I'm looking for the one I love to find me today. I don't see an absolute value. I'm sure it's in there somewhere, but I just don't see it. But I don't need that because if I put in a -1, the absolute value of -1 is 1, and 1 minus 1 is 0. So -1, 0. It's right here. -1, 0. But he doesn't own the fence, so it's an open circle. Let's put in a 2. But he does own that fence. So absolute value of 2 is 2, and 2 minus 1 is 1. So 2, 1 right there. Solid dot because he owns the fence. What if I put in a 0? Absolute value of 0 is 0, and 0 minus 1 is -1. So 0, -1 right there. What if I put in a 1? Absolute value of 1 is 1. 1 minus 1 is 0. So 1, 0 is right there. Hey, check it out. There to there. I connect the dots, and there's my V. There's the absolute value function. Find the fences, decide who owns what yard, decide who owns what fence, and then put in a bucket load of points into T-charts for each piece and graph the piece. This piece will never cross in here. This middle piece will never cross out here. This piece will never cross in there. Guys, that is it on that. That's the third page. Join me for the next page. Thanks. Bye.